Hey everyone, I, I can't take it seriously ever. It's pretty bad, guys. I need help. Seriously, seriously, I do. Alrighty, so today we're gonna be talking about, I guess, my concerns and with some of the things in the world today, and I guess how I wanna try to something in the middle of my glasses. Can you guys believe? Unbelievable. Um, Now I just made them worse. I can't. I don't know how to wear glasses. All right. So, what exactly am I upset about, and why am I upset about it? Well, this is gonna sound pretty weird, but I think something that really has been upsetting me for the last 7, 8 years has been death. It's been something that feels kind of outside of my control for at least now, and it just upsets me. And I guess it's not just the idea that I might die or I will die. It's that everyone around me, people are, suffering and dying and, seeing family members go through cancer and heart disease and, losing people. That thought upsets me, not just because, that might happen to me, but because it's happening to so many people. I don't know the exact stats, but it was like what, 3 people die per second. That's so much hurt in the world and so much pain and suffering. And for me as an individual, I just can't bear with it. I don't like that thought that all around me people are going through such difficult times in their lives. And oftentimes, I don't know about, well, obviously all of it because there's 7 billion people, but it just seems like an unsolvable problem. Just this idea of human suffering and uh, the frailty of humanity. And I'm not sure how to solve it. Because, what's the solution to death? It would have to be immortality. But I think that's what I'm trying to do with my life. It's a weird concept to think about. It's the idea of never dying or staying here forever. Now, over billions of years, you're going to lose to entropy. Or along a lot of years, you could actually survive a lot longer. But eventually, you will lose. But I guess, something that's been pushing me to do anything that I've been doing is tackling exactly why are certain people, maybe dying more early or dying at all. And, there's big causes, cancer, heart disease. I forgot that. I have a path exam coming up, and not knowing this, I'm probably going to fail. But here's the problem, right? There's individuals all around us every single day that are dying. And for me, I take a certain responsibility. And I know I don't have to, but I do. I just can't. That's, I get upset. I was watching Alex Trebek on Jeopardy the other day, and he was telling me that the survival rate for stage 4 pancreatic cancer is 18%, and that he's made it. And, that's awesome, but he's statistically going to die next year. And for me, that's so upsetting. That's just someone that I've known just gone. And the idea that that's it, that this person is going to suffer, that his family is going to suffer, that everyone who's loved him and looked up to him is going to suffer. I don't like that. And they say the pain of death never goes away, and I don't think it does. And so immortality. I think immortality is really the only solution that we have right now to this problem. I don't want people to suffer. That's really one of my goals. I when I was something like 14 or 15, and you're edgy 14, 15-year-old. I was weird. I'm pretty weird still, but we sponsored by Oral-B floss. But as we as humans, we're kind of edgy as 14-year-olds. So I was thinking, look, what the hell's the point? Like, what the hell am I gonna do on this planet? I need to set some arbitrary objective. And so I guess that objective for me was, okay, let's try to save as many people as we possibly can. and for that is immortality. So my life story, and hopefully, if I watch this video in 40, 50 years, I would have made a dent in this field or solved this problem in some way, shape, or form. It's the problem of immortality. Is how exactly can we make immortal human beings? And, what are the consequences of that? And what exactly happens if we do? So immortality is a multi-step problem, multi-step solution. And this is kind of what my approach is. So I'm in undergrad pathology. And the real reason I actually went with pathology and I wanted to study path, perhaps it had something to do with Marx. But I think something that actually got me really interested in path, if I had to pick it again, I would pick it again, is because I want to understand the problems that cause human disease, the problems that really cause death. And so whenever you're tackling your problem, you want to look, okay, here are these causes for death. And we need to address every single one to make sure that we don't, die. So there's the pathologies, the traumas, the slow degeneration of organs. I feel like those are the lower level problems that are going to be solved in 10, 15, 20, 30 years. Because those problems, are like worst case. We're going to have infinite organs in 30 years. If we can generate organs, you know what I mean? That you literally are replaceable, especially if you can make organs that are, understanding of your body's, what's it called? There's a certain word for it. Immune system, like weaknesses and defenses. That would be awesome. Another problem, let's say the on-organ problems, is sudden trauma problems. And I guess those will also be solved alongside it. So for example, it's literally a physical problem. Let's say you get a heart attack or an embolus or something that blocks your blood supply. What exactly, what do you do to prevent that from ever happening? Because when you don't have blood supply, your brain starts to die. That's just, some stuff starts to die, right? So, there's two ways of really addressing that type of problem. It's number one, make sure emboluses never happen in the first place, which, it's pretty tough. Or an interesting thing is the regeneration aspect. So if the embolus doesn't kill you completely, yeah, it probably does pretty fast if you don't act. But an ability to regenerate a brain would be pretty exciting stuff in my opinion, especially if you have damage. And I feel like, you know what would be a pretty good way to solve this? Just a system that monitors if you have any blockages, like a physical, gate or something that controls all your blood flow and everything like that to make sure that none of the stupid stuff happens and that you don't actually get mechanical breakdown of whatever. And blood supply is very important. So that's another class of problem for immortality. And I'm listing all the problems because these are things that I want to tackle in my lifetime because we need to hit a lot of things. And I'm going to start to go up in levels of complexity. Another problem is the actual degeneration at a tissue level. And that would fall into two categories. Let's say when you get older, your skin starts to lose fat. And, there's fat in layers of your skin. So that starts to make you more prone. We need solutions to that. And another problem, and I'll tell you what the solutions could look like. Fibrosis. I studied fibrosis at a lab, albeit briefly, with not too much engagement. But I was interested in fibrosis because fibrosis is one of the biggest parts of healing mechanisms in the body. Every time I hear fibrosis, I'm like, okay, this organ or this tissue's been damaged, and now it's fibrosis and it's in bad state. It's useless. It's a fibrotic organ or whatever, or fibrotic tissue. This tissue is useless, and we can't remove it, and it's just basically there. When your heart goes under damage, it heals by fibrosis. But I don't think that's the only option. And this is essentially the delivery of cellular content and the healing mechanisms of the body to ensure that the body is able to, maintain its state. So let's talk about some of the problems. Cartilage, or I don't know if cartilage is avascular. There's shit that's avascular. There's lack of vasculature to deliver content to these sites. And that, in my opinion, is problematic because our body, even if it wanted to, doesn't actually have access to a way to heal. And so we need to, as scientists, figure out, okay, how can we heal those parts? Another thing is, how exactly can we mimic the developmental processes that gave us these parts in the first place? You know, when your cartilage forms, it forms in a pretty stupid ass way. Like, if you want to emulate that, it's so difficult because the actual physical interior is different. So we need to have a way for our body to mimic cellular processes that would happen in development and in other things. You know, how exactly are we going to get fat into the middle of our cells? We need like fat channels to be embedded. How exactly are we going to get these fat channels embedded or something like that? We'd literally need fat flowing in our blood but not give us an embolus. Like, it's quite difficult, I would say, just to get this tissue to the state it is, because ultimately it could be a delivery problem, but it's also a production problem and a homeostasis problem. You know, if we want to make sure that we get fat to our tissues, if we want to make sure we have tissues that can get rid of the fibrotic tissue, okay, we have cells that can get rid of fibrotic tissue. You know, we need a way to make sure that it's replaced based on an overall goal. But the thing is, cells are blind, and I think that's a core problem with us. You know, if we are in a construction set, and I break my table, it's pretty easy. You just bring it back, you get tape, or you get another thing, and you try to fix it again. But a cell doesn't know the big picture. A cell operates on basic receptor mechanisms, and it works with certain molecules. So where are we as humans going to get these molecules from? Well, there's simply one answer, I think, at the moment, is if we want to solve tissue architecture problems, first thing, we need to understand development. We need to emulate developmental protocols in humans to make sure that we can do this and that it doesn't actually destroy us. But the thing is that we need to do is we need to actually create the infrastructure that would allow this to be possible, because at the moment, we can't heal appropriately, in my opinion. So you want to study stuff like the chameleon, or whatever. You know those lizards, you cut its tail, the tail's gonna grow back. But the tail's not as complex of a structure as some of your hypodermis, your heart. You know, these are very, very massive structures with so much complexity, protein complexity too, that I think to actually mimic those mechanisms, we would need to essentially, alter our DNA sequence. We need to alter our protein mechanism. We need to have these new mechanisms. So that synthetic biology, in my opinion, is the only solution to make sure that people around us stop dying and really stop this human suffering around us. Because at the moment, you know, clinical medicine is trying to solve things. It's when we treat individuals, a lot of times in clinical medicine, we kind of put a band-aid over an internal wound. Like, we don't do that, but like they don't do that. But what you do is you're not treating all the problems at the cause. You can only do so much with surgery. You can only do so much with drugs. Ultimately, our internal processes are flawed that we can't heal. This is a flaw in human biology. And you can see why, because evolution isn't perfect. It's not going to give you all these cool tricks if you don't need them. But we need them now because everywhere around us people are suffering and we need to solve these problems. So we need to what was I trying to say? Alter the human genotype so that it is able to do these things. So these cellular processes for repair are critical to make sure that we live in a continued state of youth, or the healthiest our body has ever been at. And I think all these protein problems with receptor desensitization or bad stuff, repair mechanisms are the solution, in my opinion, at least for the moment. And there's two more solutions, so I'll just try to keep those quick. DNA solutions and brain interface solutions, and I guess brain solutions. So DNA solutions, ultimately our DNA systems are flawed. Why? Because they mutate. And mutation is good for a species but not good for humanity because we're messing up our DNA structure and we're gonna get cancer. So we need to make sure as a species that we control the actual data of our bodies, that our data set, who we are, our DNA is consistent at least to a point where it's under control, that we don't get cancer and that we stay kind of stagnant or the same unless we want to change that. And so that comes with DNA repair mechanisms. And the thing is, I don't think that our systems we need a lot more elegance in our DNA repair systems. And I think there's a couple of bacteria that are really good for this stuff. And I know a couple of scientists are studying, but implementing it in humans is a completely different deal. Because it's like you're getting to alter every single cell. So how exactly are you going to reach every single cell with a drug or a certain treatment? And ultimately, there's light. Like, our DNA structure itself is stupid that light of certain color will break it. It just does stupid stuff to our DNA. Our DNA proteins just make mistakes. Our mistake rate for our mortality would literally need to be 0. And that's impossible because the internal structure is so bad. So we need, I guess, a way to cross-reference. And it would be pretty cool. Hear me out. If we have a way, if we can, you go to a doctor's checkup and you see an error in DNA. You know how some of your files in the computer might have errors in them? You can have an error in DNA and just go in and fix that. And then you're out and you're good. You're back to, your healthy condition and no DNA errors, and that you stay with what you had before. That'd be pretty cool. So that's that. Just the actual DNA structure is just dumb. We need to fix it. I think biologists worship the human body, natural mechanisms, for good reason. They're elegant, but they're imperfect. So we need to balance out, this elegance and this imperfectness, because right now what we have is cool. It works. And it works for reasons actually we don't understand. So we obviously need to understand those reasons, but we also need to make sure that, okay, look, what we have here is not the final product that is going to solve this problem. Ultimately, we can't live forever with what we have. I'll tell you right now, there is no treatment in this industry that's going to keep you living forever, because who you are as a person is being corrupted every single second. Your actual DNA code, it's like your assignment. Let's say you have a 1,000-word assignment. Your letters are starting to mess up. Sure, you can still get a big picture, but after 100 years or something, your assignment's going to start looking pretty different because so many letters are out of order that you aren't you anymore. You're just a collection of mistakes over 100 years. Now, this sounds pretty aggressive, but essentially, the DNA code is going to continually deteriorate. And if you want to live forever, we need to make sure that it can withstand and be repaired over long periods of time. And the actual solutions, it's pretty cool to look at storage devices and storage systems, because I think those are pretty elegant, and just seeing how those work. And I think before that, I guess, just to add a 5th point before I get to my actual 4th point, because I don't have any organization for these videos, is correct, accurate targeting of cells. Now hear me out. You remember how I said we need to add receptors to alter the protein biochemistry? Well, here's the thing. If we alter the protein biochemistry of every cell, how exactly can we make sure that the kidney cell is still going to work as a kidney cell, and that our drugs are going to target kidney cells and not other cells? Because this is a core problem with cancer, and it's essentially, we don't know what cells are cancer cells because our own cells are cancer cells. So we're going to destroy our own cells. So we need a way to actually specifically target what we want to target, and specifically touch what we want to touch in our body, so that, why do I say the words that sound so weird? But you get the idea. It's that we need to be able to specifically, accurately attack targets. And the specific targeting, I feel, is going to be the solution to cancer, at least temporarily. And now this thing is going to come later. But I feel that there has to be a way where we can specifically target cells, any cell in the body, based on will. And I think that's when we start getting closer and closer to immortality, because that's, when we can start implementing the solutions like changing the protein biochemistry. I need to change my eyebrows, ? Hashtag like and subscribe if you agree. I don't get how those YouTubers say it like seriously or anything like that. It's kind of weird. But I think that's a pretty big aspect. But I think a top tier solution is asking, what exactly are you? What are you? Are you your arms? If you lose your arms, are you still you? If you lose your legs, if you lose anything other than your spinal cord, and even your spinal cord, I don't know if spinal cord is part of consciousness, are you still going to be you? And the answer is yes, because you are your brain. You're actually, if you think about it, you're a brain sitting in a like a skeleton armor with basically another suit of muscle and tissue to cover you up. That's really yeah, and that's how the human body split up. But literally, you're just like a container for a brain. You're a walking brain, and it's pretty weird to think about. But that's just kind of that's the truth. Like, if you reduce the complexity of the body, you are still yourself till you start cutting out your brain. And so, an intuitive answer, or maybe not too intuitive, is what if we can just take out the brain and create new bodies for that brain, or create new interfaces so that our brain can live even if our body dies? Because our tissues are only ever going to be so advanced. Ultimately, we're working with carbon. There's chemical instabilities within our structures. But that doesn't necessarily have to always be the case. The idea is that we are a set of information that can be stored. Man, what? Okay, there's a certain thing that's pissing me off. Okay, we're good. We're a set of pieces of information that are stored, I guess, in different places, in our brain and connected. So if we can maintain informational continuity, then we can, in theory, live forever. And what I mean by that is, what if we have a device in our brain that can connect us to the internet? And our consciousness, we slightly start to be aware of the internet. And we're kind of like in multiple places at once. We can slowly seep out the, I guess, consciousness from your body and slowly transfer it to the internet. As long as there's no break in consciousness, you should still be you. But spread out. Immortal. If you can do it properly. And so, this transfer of information for our brain is perhaps the last stage. Because ultimately, what we are is a series of conscious neurons that are aware, for some reason, of their existence. And that's pretty cool. But is it possible? In my opinion, it is. I think it's going to be a long process, highly complicated. And there's a lot of ethics, what exactly is a human being and what defines our consciousness. But I think that solution is the final one, because ultimately the diseases that kill us the most, in my opinion, you're dead, but diseases like Alzheimer's and dementia are killing you, not your organs. You are yourself are dying. When your organs die, what happens is you can't function. Your brain, you are not receiving the proper support that you need, and so you start to die. There's complications too, but essentially, when you get a heart attack, the reason you die isn't because your heart stops working. It's because your brain stops working. You can live without a heart. If you can, I guess, manually pump the blood, you're still good. But the second your brain dies, you're dead. And that's a pretty interesting thing to think about. I think I talked about it. As long as we can maintain a continuous flow of brain information, we're good. Because think about it this way. If I were to take your brain structure 10 years ago, let's say you're 30, and I were to compare your 20-year-old self versus your 30-year-old self, there's going to be some significant differences. And if you were to jump from your 20-year-old personality to your 30-year-old personality in a second, would that still be you? It's a very important question. Now, if you were to be so altered, you're like, oh, you're so different. And I don't think it would be you. I think you would be dead. Because essentially, your continuity of consciousness is gone. And you're just a new individual. Think about it this way, too. If I were to die, wait 5 years, have my brain structure altered significantly and come back, Yeah, I'm back to life, but is that person me? Like, is my consciousness still alive? And that's a very important question to ask, and I think that's something you want to think about. But I think those 5 solutions are generally my approach to solving immortality. There's obviously a bazillion other ones, but I think the high level, the tissue level, the protein level, the DNA level, and the brain level, and the information level is a solution to make sure that all around us in the world, people stop dying. And I want to echo, we're on a crunch for time. I think this is what people don't get. There needs to be urgency when we tackle these problems. Because every single second, someone is dying. And for me, death is a pretty serious thing. We're kind of taking our sweet time in research with these things. People are going out for donuts, and that's okay. But ultimately, I don't think we're maximizing the efficiency of the system. And that's pretty sad, because I think we could do so much with what we have right now, but we're just not moving fast enough. 3 people every second. Like, can you believe that? 3 people every second die. I can't wrap my mind around that. It's, in my opinion, it's 3 people every second, I'm wasting time, or I'm not being fully maximized in my efforts. 3 people I've kind of let down. But that's not it. That's 3 people's families, friends, peers that are let down. And I don't know. I find that pretty sad. Because ultimately, I think my time here on Earth, however long it is, it's a time of service to those who need me the most. And that's those people, the people who are losing their families every single second. And, however long I live, I think that's my life objective is tackle this problem. Make sure that we as a species can live on. And then after that, we can talk about the philosophy about living forever and the utility of that. And I think that's my previous video of, like, what the hell's the point of living forever? But I think we can think about that once we get there. Because at that point, we would have satisfied our objective. And I think I'm an objective-based man. So hopefully in the next 30 years, there's something. Just, so weird, the idea that one day you're just going to stop existing and just poof. And that 3 people every single second are going through that existential dread to a certain extent. Not everyone feels that, but many do. And even those who don't, their family and everyone around them. It seems that we kind of, death is this thing that's been, like, the seriousness of death is not truly appreciated. What am I doing with my hair? I don't know. I really don't. I'd rather just, like, start going like this. I call it stress twirling. Because this topic stresses me out. Alrighty. That's my mini rant for today. I really just see. I want to start this video talking about my objectives and why I think we want to tackle it. Because I think I mentioned in the other video, like, I need to solve these problems. People are dying. Like, we need to move. Like, I can't. Like, do you not get upset when you see someone die and that you could have done something about it? I feel like as a child, I always thought someone else was going to do these things and someone else is going to solve these problems. But no one else is solving these problems. So I feel like that responsibility is on me. And I know I can't solve all of these problems. It's impossible. Like, I just don't have that much time. But I just feel, I don't know. Work needs to get done. I think that's what I'm about to go do. Put my head down, understand some content. I think get some better scientific knowledge is something I need to do. I want to go to med school for a lot of reasons. But I think that cumulative knowledge about the body will help me address this problem a lot more efficiently. And with that being said, thank you guys so much for watching this 30-minute video. Oh, it's 30 minutes and 1 second now. But if you have any questions or long ass comments without ad hominem, please leave those below, and I'm willing to just chat. And if you have any solutions to immortality sauce, please. Yeah. All right, guys. Hope you have a great day or night or evening or afternoon. I don't actually know the difference between evening and afternoon, and that kind of upsets me a bit, but whatever.